Hey guys, today's video we're going to be checking out the MicroSwiss NG Extruder, and this is their brand new direct drive next generation extruder. Now, I was one of the lucky few to have had MicroSwiss reach out to me to ask me to test one of their pre-production models, and so I've already been using this thing for quite some time now, and I can tell you it is excellent. It's been super reliable and the prints come off very clean. Now, there's a few other installation videos floating around out there. I'm gonna be doing mine on a Creality Ender 3 V2, and the reason that you're watching mine is because obviously it's going to be the best, but I'm also gonna throw in a CR Touch install, and if you guys are paying close enough attention, we're also gonna be doing a firmware install, and I'm gonna show you how to customize the splash screen on your firmware installation. So let's get started. As always, we'll start off with an unboxing, and the first thing you'll notice is the nice, simple, and recyclable packaging from MicroSwiss. Once you open the box, you'll be greeted with an instruction card with the QR code where you can find step-by-step instructions. And behind that is the NG itself, nestled nice and safe inside of the box. The unit comes mostly pre-assembled, and you can see here that it features a really high-quality LDO stepper motor up on the top. And in typical MicroSwiss style, you have a very nice aluminum machined bracket on the back, which essentially replaces the entire X carriage on your Ender series printers. And on the front, you have a very nicely printed fan shroud in a matte black PETG. And behind the NG in that same box, you'll find the necessary hardware to install the MicroSwiss NG, along with extra spare hardware, which is really nice to have, the heater block, heat break, and the nozzle in one bag, along with a silicone sock. And then you'll find the extension cable for your new direct drive stepper motor. And so we can start our disassembly by snipping the zip ties closest to the print head. And from there, we're going to flip the whole machine around so we can access the back of the print head. And this is how we're going to remove the fan shroud. So there are two button head cap screws on the back of the print head, and you're going to remove those, and that should release the plastic fan shroud from the front. With the fan shroud released, you want to carefully put it aside and try not to pull on any of the wires leading down to the heater cartridge or thermistor. You should be able to rest it on the X gantry aluminum extrusion, and then you can remove the Creality silicone sock and take a look underneath of your heater block. There'll be a grub screw holding your heater cartridge in place. You'll need to loosen this grub screw in order to release the heater cartridge from the heater block. On the side of the heater block, you'll find a Phillips head screw. You need to completely remove this, as this retains the glass bead thermistor. And with that out of the way, you can now completely remove the heater cartridge and thermistor from the heater block. Now we have better access to the fan shroud, and we can begin removing the extruder heatsink fan. And so looking at the inside of the shroud, you'll see the screws that are holding that fan in place, and you are simply going to remove those, and that fan should come out of the fan shroud. There is one remaining screw left inside of the fan shroud, and you can see it here in the bottom left-hand corner. You're going to need to remove that in order to remove the part cooling fan. Next, we can remove the Bowden tube by depressing the fitting and then pulling up on the PTFE tubing. And if you're like me, you forgot to remove the filament before this entire procedure. So you can just take some side cutters and cut some of that off. Just leave enough so that if you ever have to use this assembly again, you can manually push the filament through by hand. At the right-hand side of the Ender 3 V2, there is a blue tensioning knob. You're going to want to release all of the tension off of the X belt, and then flip your printer around so you have access to the back of the print head again. At the bottom of the X carriage plate, you'll find the ends of your timing belts, and you can simply pull those out of the slots. And finally, you can remove either the top two V wheels or the single bottom V wheel with the adjustable eccentric nut, and that entire assembly will now come right off of the aluminum extrusion rail. Now we need to transfer over our original V wheels from the Creality assembly onto the NG assembly, and to do that, the first thing we do here is remove the fan shroud. There are two screws on the side. They are small button head cap screws, and once you undo those, the entire fan shroud should come right off. Carefully set those screws aside and do not lose them, because of course you will need to reuse them when you want to put the fan shroud back on. While we have the fan shroud off, this is the perfect opportunity to take a look inside of the NG and really appreciate the work that MicroSwiss has put into this extruder. You can see these interesting channels here, which I believe are intended to act as a heat sink because they are very close to the heat break. And it looks like they are meant to direct air coming from the extruder fan away from the heater block. Most notably, you can see the bevel gear drive on the inside, and this allows MicroSwiss to position the stepper motor in this very unique orientation. And the advantage to this is a very short filament path. They advertise the path as being 41 millimeters, which might be one of the shortest in the industry. Additionally, it keeps the mass of the stepper motor close to the carriage and therefore reduces the amount of torque or moment acting on that carriage. And overall, I'm just constantly impressed with the value you get with these MicroSwiss kits. Their machine work is outstanding. And now that we're finished admiring the new equipment, you can take your old and sad looking Creality carriage and you can remove the 3 V wheels. Your new MicroSwiss kit should come with everything you need except for those V wheels, so you should be able to just discard everything else. In the hardware bag, grab the longer of the 3 M5 button head cap screws. Place this screw through one of the V wheels, and then on the other side, place the included eccentric nut through that screw. Pay attention to the orientation of the longer boss on the eccentric nut. The longer boss on the eccentric nut will pass through the new X carriage plate and locate it onto that plate. Then you can take the M5 washer and M5 locking nut and start to snug up this hardware. Do not completely tighten it down just yet, as we are going to need to make adjustments to that eccentric nut. Heading over to the back of the machine, you can now remove a few things to make some room to work. So the wiring harness will pop right off of the back of the original Bowden tube extruder, and then you can try and remove your Bowden tube. If it's really stuck like mine was, you can just grab your wrench and remove the fitting, and the entire thing will come free. After that, you can take the NG and position it onto your gantry. Grab the remaining 2 V wheels along with the 2 M5 screws left over in the hardware package, and you're going to screw those directly into the X carriage bracket. One of the V wheels will line up very easily, and the second may or may not line up correctly. If you're struggling to get the second one to line up, this is because of the eccentric nut. You may have it positioned into a very tight position, not allowing for the alignment of the final V wheel. In this case, grab a 10mm wrench and make some adjustments to that eccentric nut, putting it in a loose position. This is why I had suggested in a previous step not to fully tighten the lock nut for the bottom V wheel. Now you should be able to fully tighten the 2 M5 button head cap screws that hold the 2 top V wheels in place. Adjust the bottom eccentric nut such that there is no play in that carriage. Do not over tighten this eccentric nut. If you are finding that while you slide the carriage back and forth, it feels as if there is a flat spot on the carriage, then you know it's too tight. Try and find the sweet spot where the assembly is free running back and forth, but there is no slop or play in the carriage. Then you can tighten the lock nut on the bottom V wheel. Removal of the Creality Bowden extruder is extremely simple. Just remove the extruder knob off the top, and then you can remove the tensioning screw at the back. This will release the tension on the tensioning arm, and you should be able to remove the spring. After that, you can remove the single screw holding the tensioning arm into place. You'll find it located right on the top of the tensioning arm itself. Completely remove this and the tensioning arm will come off as well. After that, you can remove the final 3 M3 screws holding the extruder stepper motor to the bracket. They're all accessible from the top, and as you remove them, be sure to keep your hand underneath of the stepper motor, because once these screws are released, the stepper motor will just fall down. I didn't mention it at the beginning of the video, but whenever I'm doing work like this on my printers, I like to remove my glass bed. Accidents happen, and sometimes large and heavy items fall onto the print bed, such as stepper motors, and that will lead to a broken glass plate. When the final 3 screws are removed, all of the remaining equipment will come right off of that bracket. Now we can reattach our timing belt, and looking under the X carriage, you'll see that on the right hand side there is a single slot for your timing belt. On the left hand side there are 2 slots, and the innermost slot is meant for the Ender 3 V2, whereas the outer slot is meant for a regular Ender 3. Now you can use the tensioning knob on the right hand side of the printer to retension your X belt. Installation of the heater block, heat break, and nozzle are next. You can remove them from the package, and then you can go ahead and remove the silicone sock from the heater block. This is yet another fine example of machining and manufacturing from MicroSwiss, and we're going to be inserting the heat break into the bottom of the NG Extruder assembly. Orient the heater block with the split in the heater block facing the front of the machine, and then use the grub screw on the extruder assembly to tighten down onto the heat break neck. These are fairly small pieces that you're working with, so you do not need to over tighten that grub screw. Now I seem to have lost the footage for the installation of the thermistor and heater cartridge, but luckily it's very simple. The thermistor is installed into the smaller bore on the right hand side of the heater block. It is retained with the small Phillips head screw that was included in the same package as the heater block. The heater cartridge slides into the larger of the 2 bores, and it's clamped into place using the 2 screws on the bottom of the heater block. And now we can work on getting the fan shroud and other various bits and pieces into place. And so we're going to take the part cooling fan and remove the smaller fan duct if you haven't already done this, and there are just 2 screws on the back, and that fan duct will come off of the part cooling fan. Then you can reinstall the silicone sock over top of the heater block, and then position the fan shroud onto the assembly. While you're doing this, be cognizant of the heater cartridge and thermistor wires. It's pretty easy to get them caught up in the fan shroud, and you don't want to pull on those things too hard. So try and push them in towards the center of the assembly, and then get the back of the fan shroud wrapped around them so that you can get the screws positioned in place. And once you get those screws aligned, you can tighten them down, and the entire fan shroud will now be held into place. We can install the extruder fan next, and in your hardware kit there are some thread forming screws. There should be 4 of the larger variety, and they will attach the extruder fan to the fan shroud. Now we can tackle the part cooling fan, and it will sit inside of the little pocket on the side of the fan shroud, and of course the outlet of that fan should be pointing down into the duct. Once you have it positioned correctly, go back into your hardware kit and find the smaller of the thread forming screws. They will secure the part cooling fan into place, and as you tighten them, they will cut their own threads into the 3D printed plastic fan shroud. At the top of your extruder assembly, you can insert a very short piece of PTFE tubing, and then you can lock the push fitting in place with the retaining clip. Included in your kit was a stepper motor extension cable. Only one end of this extension cable will fit onto your stepper motor, so go ahead and plug that end in. The connector is keyed, so you cannot plug it in the wrong way. And at this point, I'm not going to sort out the wiring bundle just yet, because we're going to be doing a CR Touch install, as I had mentioned at the beginning of this video. If you are not doing a BL Touch or CR Touch install on your machine, you can use the YouTube chapters feature in the progress bar of this video to skip ahead to a later chapter where I will be addressing the firmware modifications necessary to change the E-steps for the new extruder. And if you're not familiar with the CR Touch, it is basically Creality's version of the BL Touch module. Now I've covered the installation of one of these on an Ender 7 printer, and if you guys want to see that video, I'll put a link in the top right hand corner of the screen. Depending on where you got your CR Touch kit from, some of these kits include mounting brackets for popular machines like the Ender 3 or the CR10s. I did not need those brackets because I knew that I was going to be using a 3D printed bracket compatible with the NG Extruder. The STLs for that bracket can be found on the MicroSwiss website, and they should be compatible with BL Touch modules as well, because the mounting pattern for the CR Touch and BL Touch is identical. In the CR Touch kit, there are 2 sets of M3 button head cap screws. We're going to be using one of the longer ones to attach that CR Touch bracket to the NG X carriage. However, looking closely at the CR Touch bracket, you'll see that the holes are intended for countersunk screws. Now, to save you from having to run out to the hardware store for 2 tiny little screws, you can actually salvage one of your countersunk screws from your Bowden tube extruder assembly when we disassembled that earlier in the video. And that's going to go into the top position of this bracket. In the bottom position, we can use the aforementioned button head cap screw that came in the CR Touch kit. There's enough clearance between this bottom screw and the CR Touch module such that you don't have to use a flat head screw. Now you can use the shorter screws from the CR Touch kit to secure the CR Touch module to the bracket. Position the connector opening of the CR Touch module towards the outside or left side of your extruder so that you'll be able to plug the module in later and there's no interference between the plug and the bracket. And now we can take care of some wire management, and we're going to take the CR Touch cable along with the extension cable coming off the stepper motor. We're going to loop those together and tie them back into the main harness, leaving some slack, and you can see I've got some zip ties there holding them onto the tensioning lever of the extruder assembly. I recently ran out of wire loom, and so later I'll come back and replace this whole thing with some split wire loom, but in the meantime I've held all of the cables together with some zip ties just loosely. I'm also going to connect the extruder extension cable to the original extruder motor connector. The CR Touch wiring harness is going to need to be connected to the main board of the printer, and so we are going to need to gain access to the main board. There's 1 screw on top of the printer and 3 on the bottom, and once you remove those screws, the panel for the main board should come right off. Just be aware that there's a fan connected to that panel on the bottom, so do not pull off too quickly. With the main board exposed, you're going to route your CR Touch wiring harness down to the main board, and that 5-pin connector will plug right directly into the 5-pin receptacle on the main board. And while you're down there, take note of which revision of the main board you have. It's written on the board under the Creality logo. And with that complete, just tidy up your wiring and then replace the cover for the main board. And with the machine back upright, this is a good time to reposition the spool holder. And I like to offset it off to the right hand side of the machine, and that's going to allow the filament to loop down directly into the new direct drive extruder. And speaking of spool holders, I recently designed this Creality smooth spool holder, and I made a video about that, and you can find the link to that video in the top right hand corner of the screen. You guys can download those design files for free. There will be a link in the video description to my printables page, or alternatively, if you'd like to support my channel, you can head on over to my website, embracemaking.com. And these are also available for purchase along with a variety of other items. YouTube certainly doesn't pay the bills, so any support for my work is greatly appreciated. Now we can power the printer on, and if you've installed the CR Touch correctly, you'll notice that the probe cycles as soon as the machine turns on. Now, if you didn't install a CR Touch or BL Touch module and you only installed the NG, you won't need to do a full update on the firmware. I'm going to go through that process right now so we can fully utilize the CR Touch auto bed leveling procedure, but for the NG, all you will have to do is update the E-steps. MicroSwiss has made that extremely easy to do by just creating a very simple G-code file that you can run that's going to change your E-steps and then save it. That file is available on the MicroSwiss Thingiverse page, and I'll put that link in the video description down below as well. Now we can do the full firmware update. And again, this is not necessary if you've only done the MicroSwiss NG install. This is what I would recommend if you've done a CR Touch install. Right now I'm on the GitHub page for the very popular Jyers Firmware, and as you can see, there are many different versions. Earlier I had recommended that you should have taken note of the hardware version of your main board. And the reason for that is that the firmwares here are compatible with certain versions of the main board. And so I have a version 4.2.2. And so I'm going to go ahead and download the 4.2.2 version with the 5x5 BL Touch mesh. And then down at the bottom, I'm going to download the full source code, and that's where I'm going to get my screen files because we're going to update the screen as well. Now to update the firmware on the main board, you just take that file that you downloaded, the bin file that matches the hardware version of your main board. You're going to put that onto a freshly formatted SD card. It should be 8 gigabytes maximum. Put that into the printer and then simply turn the printer on. It might take a few moments, but the screen will eventually come on and you won't even notice the difference. Not yet anyways. Now to update your screen firmware, you have to access the back of the screen. And so that screen just pops right out, lift up and pull out, and then you can remove the connector on the back. Remove the 4 screws on the back and that cover will come right off, exposing the circuit board underneath. Now we need to prepare an SD card for the screen, and you're going to unzip the source code file that you downloaded from GitHub and open up the Marlin directory. Inside you'll see another folder called Display Firmware, and inside of that you'll see a folder called Firmware Sets. And inside of that folder there are 3 different firmware sets. One of them is called Gotcha. Now I read online this is a good one. I don't know all of the small differences between these, and so if you guys happen to know, please let me know in the comment section below what those differences are. While you're in here, there's an opportunity to customize the splash screen of your printer. When you open the firmware folder, you'll see a file called 0_start.jpg, and this is a splash screen of your printer. You can edit this file in any image editor that you like. You just have to save it as a JPEG, and it can't just be any JPEG, it has to be a baseline JPEG. And if you don't know the difference between progressive and baseline JPEGs, you can just have a quick Google search on how to save it as a baseline JPEG in whatever image editor that you're using. Replace the old file in the folder with the new one, do not change the name, then head back up 1 level and rename that folder. You want to get rid of all of the information in the parentheses, so it's just the dwin_set, nothing else. Copy that folder onto another freshly formatted SD card and make sure there are no other files on there. The SD card should be 8 GB max. Take that SD card and insert it into the SD card receptacle at the back of the circuit board. Don't put the back cover on just yet because we need to get the SD card back out, and if you did something wrong, then it's very easily accessible still. Plug the connector from your printer back into the back of the screen and then turn your printer on. It should only take a few seconds and the firmware will be flashed onto the screen, and you'll be presented with a blue screen and then a red screen. Red usually means something's bad or wrong, but in this case, that's a good thing. Remove the SD card from the back of the screen, put the cover back on, and reinstall it back onto your printer. Now when you turn your printer on, you'll be greeted with the new splash screen, and if you modified that screen, you'll see that come up. The new Jyers screen firmware can be much more colorful and very highly customizable with so many more features. Since we now have a CR Touch or BL Touch module installed, along with the compatible firmware, when you go to home your Z axis, you'll find that the printer is now using the probe to home the Z axis instead of the original limit switch. And so if I trigger the limit switch while the printer is trying to home, you'll see that it does nothing. Because of this, we can just move that entire assembly out of the way, and so loosen the 2 socket head cap screws off of the side of your limit switch and move it down and out of the way. There are a few more housekeeping items to take care of here, whether or not you've installed the CR Touch or just the NG Extruder. One of the things you need to do is to modify your Z offset. After that, I like to do a manual print bed leveling, and this is because although we have a auto bed leveling system, I don't want that system having to compensate too much. Your bed should be as level as possible from the start. Once the manual bed leveling is done, you can head on over to create a new mesh. This will use your new CR Touch or BL Touch to create that bed level mesh. Depending on the firmware that you installed, it could be a 5x5 or a 3x3 grid. And this process takes a little while, so be patient. In this video, I've clearly sped it up. Don't forget to head into your slicer and make some changes to your Start G-code if you did the CR Touch or BL Touch upgrade. You do not need to do this if you only did the NG upgrade. In your Start G-code, take a look for the last call to G28, and underneath of that, you're going to input M420S1. This is going to load in the last mesh and ensure that auto bed leveling is enabled through your print. Now for the direct drive setup, you do have to do this part, and you're going to head over to your extruder settings and change your retraction length. Reduce it to something around 0.75 millimeters or 1 millimeter. I've also changed the retraction speed to 35 millimeters per second, and I did not change any of the wipe settings, but that might be something that you have to tune or play with your particular printer and the material that you're using. And before you get printing, the last thing that I would highly recommend that you do is do a PID Autotune on your hot end. It is a really good idea to do this anytime you switch out any of your hot end equipment, and that's because you want the most stable hot end temperature possible. Large fluctuations in your hot end temperature can actually show up as print artifacts. The PID Autotune can be run directly from the screen firmware, and therefore you do not have to connect any sort of external print host, so it's very convenient and easy to do, and there's no reason not to do it. And now that you have everything dialed in, it's time to lay down some plastic. So far, the NG has been extremely reliable for me. As I mentioned at the beginning of this video, I've already been running it for quite some time now, as I had access to a pre-production model. The only issue I ever had was a little bit of under extrusion, and that was because of user error. My issue was that I did not have the tensioning knob adjusted correctly, and that's the brass knob on the tensioning arm. Turn it clockwise for more tension and counterclockwise for less tension. And so that's it for this video. A big thank you goes out to MicroSwiss for sending me that pre-production model as well as a full production model. So I actually have two of these things running day in and day out on my print farm, and I've been putting them through their paces, everything from PLA to carbon fiber materials, and the only modification I had to make for the carbon fiber stuff was a hardened steel nozzle. Otherwise, they've been printing flawlessly now for days and days and days on end, almost completely non-stop. And if you guys are enjoying my videos, I would highly encourage you guys to check out my website, embracemaking.com, where you might find something that you like. Any purchase made on my website obviously supports me, my channel, and my work. I'm now carrying double-sided magnetic flex plates. You can see the smooth side has my logo on it, and the other side is textured. I carry a few common sizes, but if you guys have an obscure printer or a custom size that you want made, I can get that made for you. So check it out, embracemaking.com, and I'll see you guys in another video.